Looking at these stars, suddenly dwarfed by my own troubles and all the gravities of terrestrial life, I thought of their unfathomable distance and the slow, inevitable drift of their movements out of the unknown past into the unknown future.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Matt, That's quite strange because haven't you got quite a lot of slow, inevitable drifts of your movement?
No, I'm regular as clockwork. I'm like a Newtonian galaxy.
You're still eating enough fibre?
Regular as clockwork.
Well, Matt, I think I'm glad to hear it. And I'll tell you what, H.G. Wells, who that lovely quote was from, would be glad to hear it too.
Oh, absolutely. He was very concerned about people's movements, as we heard in the quote.
As he should be, as we all should be. So, Matt, how are you? Are you all right?
I'm very well, thank you. A little bit hungover from the beer that you were giving me yesterday.
Yeah, I gave you some strong beer, didn't I?
You didn't warn me that it was like 7.8 or whatever it was. It's ridiculous.
I'm preparing you for when we go to Mars, Matt. That's all we're going to get.
It did have the sweet taste of free.
That's your favourite price, isn't it?
It is my favourite taste in beer.
Oh, yeah. So, yes. Matt, let's talk about On This Day.
On this day. So, yeah, Friday, 1990... was the classic Magellan space probe, which reached Venus on this very day, 1990. The Magellan space probe.
I mean, that's if you call something epic, that's it, isn't it? That's an epic thing.
Oh, we need to send more stuff to Venus. It's actually ridiculous how it's completely overlooked. And Mars this, Mars that. Come on.
It's all about the red planet. What about Venus, Matt?
Is it because Mars doesn't rhyme with...
I think that's exactly why no one talks about Venus. Yeah, it's just a bit embarrassing.
It is a bit embarrassing, isn't it?
Yeah. And God knows, Matt, you know that I do not like a euphemism. So I'm sticking well clear of it.
And Saturday, Jamie, is the 49th anniversary of the Apollo 11 astronauts being released from their 3-week quarantine.
That's amazing. You know what, Matt? Next year for the 50th, I think we should get our mate Al Worden back on the line.
We need to desperately need to get that dude back in next year, and I'm sure he'd be more than happy to do it.
Get him on Skype for the 100th.
Yeah, big time.
We'll ask him.
So, here we go. Follow the account at Apollo_50th. They're doing the whole history of Apollo program. They're tweeting it. Every mission, every event.
Epic. Give them a follow. And if you like what they say, why not bang a retweet out?
Do it.
Hey, Matt, you know what it's,
retweet,
you know what it's time for now, don't you?
Is it Space Legend of the Week?
Happy 99th birthday, Eleanor Margaret Burbidge.
She was born Eleanor Peachy. Well, that's a great name, isn't it?
It's a great name.
But get this, it's her 99th birthday on Sunday.
Oh, happy birthday, Eleanor. Amazing.
Which actually puts her in the kind of same age bracket as James Lovelock.
Another great name.
Another great person and great
Imagine
name.
if Peachy had married Lovelock.
Peachy Lovelock.
They would both want to keep their surnames, wouldn't they?
She didn't marry James Lovelock. She actually married Geoffrey Burbidge. And this is going to be pretty important. But anyway, so yeah, Eleanor Margaret Burbidge is one of the most important astrophysicists of all time. Born in Devonport in Great Britain, she's now an American citizen and has been for some time, since 1977, in fact. And she's been the director of the Royal Greenwich Observatory. She's been at University of London Observatory, the Yerkes Observatory in Chicago, Cavendish Laboratory in Cambridge, the California Institute of Technology, and she's most associated with the University of California, San Diego,
right,
where she's worked since 1962, and she's the emeritus professor still at the age of 99 there, still working on like amazing stuff.
If that doesn't inspire you to get up off your ass, I don't know what will, Matt.
No.
She's still rocking it at 99. That's amazing.
She did, and she helped develop the spectrograph in the Hubble Space Telescope and discovered a massive black hole at the centre of M82.
Whoa.
So she's still going and still doing stuff. But her most famous contribution, which she made with her husband Geoffrey, and really, quite surprisingly, she hasn't won the Nobel Prize for this, but it's called the B squared FH theory. It's called B squared because it's Burbidge, Fowler, and Hoyle. Fred Hoyle, of course. And actually, the Fowler in that list won a Nobel Prize for something else. So it's a very distinguished list of people. But they came up with how basically stellar nuclear synthesis.
God, that's no easy task.
Yeah, stellar nucleosynthesis.
I mean, they just beat us to it, Matt.
So all the chemical elements might be synthesized in stars. That was their amazing insight, which obviously led to people like Carl Sagan saying we're all made of stardust.
Absolutely.
So, yeah, she's not someone that you hear of very often, but she's clearly an absolute legend. And it's her 99th birthday on Sunday. And she's not only that, she's quite famous because she was the first director at the Royal Greenwich Observatory, which was the first time in 300 years that post wasn't associated with the Astronomer Royal. And she said that it was sexism that allowed that to happen.
Right.
She's actually turned down some prizes because she felt that they were sexist, but not sexist in a anti-women, but anti-men. So in 1972, she turned down the Annie J. Cannon Award of the American Astronomical Society because it's awarded to women only. And she says, "It's high time that discrimination in favour of, as well as against, women in professional life be removed."
She basically just gets more legendary as you go on.
Oh, yeah, so she's... And 12 years later, the Society awarded her with its highest honour, which is the Henry Norris Russell Lectureship. So that is like the highest honour you can win from there. And she's got lots and lots of, different awards as she's been going around doing her thing.
Is Henry Norris Russell in any way related to you, Matt?
Bound to be. Yeah. Henry Russell?
Well, you are related to Churchill, aren't you?
Related to Churchill, but more important, I'm related to the Russells of the Dukes of Bedford. So if Henry Norris is in that line, then yeah, possibly.
Well, there we go. Possibly, check it out.
Me and Uncle Bertie Russell as well.
Happy birthday, yes. Eleanor, for Sunday. I'll be raising a drink on Sunday in honour of you. And
99.
Matt, long may she continue.
So she was 50. Get this. She was 50 when Neil Armstrong was on the moon. That's just rad, right?
Wow.
Yeah. That is just mental.
I'll tell you what else is rad, Matt.
Mm-hmm.
Are you ready for the space word of the week?
Space word of the week. Do it.
Sidereal time. Sidereal? You say sidereal. I say
sidereal. No, sidereal.
Matt, this is yes. Time relative to the stars other than the sun.
Yeah, so as the Earth rotates, instead of using the sun as the reference point, like 24... Basically, in 24 hours, the sun is in the same place each day, right? So you look at 2 p.m., the sun's there, and then 24 hours later, it's in the same place. And that's the time relative to what's happening with the sun. But what if you do the same thing relative to the stars is called sidereal time or sidereal time. And it's pretty important. It's in astronomy, it's probably more important. So for a given observation point, a star found at one location in the sky will be found at the exact same location the next night, 24 hours later, in sidereal time, but not in real time. So roughly, a sidereal day or a sidereal day is 23 hours, 56 minutes and 4 seconds. In fact, 4.0905 seconds to be precise.
Matt, let's be precise.
Yeah, we are going to be precise. But the most incredible thing about all of this is that it's actually not quite precise, because there is this weird thing called precession that the Earth suffers from. So the March equinox... It has precesses, and that's a sort of gravity-induced, slow and continuous change of the orientation of a rotational axis.
Oh, I was about to say that.
So not only is the Earth spinning on its axis, but it's got a kind of wobble. And that gradual shift takes 25,772 years to do a cycle.
Jeez.
So you have to factor that in as well. And actually, that's known as the Earth rotation angle, which is the true sidereal period. So there's a bit
Matt, let's be honest.
Yeah.
If you were rotating as fast, you'd wobble too, wouldn't you?
Mm-hmm. Yeah, absolutely.
So
0.0084 seconds shorter than it should be. So there's 8/1000ths of a second from sidereal time to Earth rotation angle, or ERA.
So the slightly longer true sidereal period is measured as the Earth's rotation angle, or the ERA, formerly the stellar angle. An increase of 360 degrees in the ERA is a full rotation of the Earth. Is that right?
Yep, exactly. Bang on. And yet it wouldn't quite be that if you weren't taking that huge 25,772 year cycle into account.
Yeah.
So I think a lot of this, so these changes from the ERA and the sidereal time were made in January 2003, and it was because of basically much better ways of measuring how the stars were changing in position over these periods and actually getting this precession exactly right. So, and that was done using very long baseline interferometry, or VLBI.
I like the sound of that, Matt.
How cool is that?
Yeah.
Everywhere has their local sidereal time as well, sidereal time. But the kind of standard one is based where, do you think?
Well, it's got to be Greenwich, isn't it?
Yeah, of course. Get in, Greenwich.
Just saying.
Yeah, absolutely. So, space
Matt, how cool
word
is it at Greenwich Observatory when they point the laser down into the city?
Oh, yeah, it's really cool. Jamie, some sad news, and I know that you are a massive fan of all this.
Go on.
But asteroid mining is not going very well at the moment.
I was so excited about it, and now everyone's shooting me down.
Yeah,
What's happened now?
It hasn't had a very kind response. I still think that there's something in asteroid mining. I'm with Jeff Bezos on it in the kind of flipped industry model. But here we go. Planetary Resources, which is like the kind of big player in this, is in financial difficulties. It kind of missed a funding opportunity, and now it's really, really short of cash. So it's selling all its CNC machines and 3D printers and laptops and stuff like that, and laying off loads of workers.
Selling their folded chairs? That can't be right.
Selling their folding chairs. Yeah, I think that. I've been just selling everything.
Are they having I imagine this taking place in a car park, like a car boot sale.
Like a massive car boot sale, sometime in the next couple of weeks.
CNC machine, anyone? £10.
I'd love it. I'd love a CNC machine. It'd just be the best thing ever.
Yeah.
But, if you can get yourself down to where Planetary Resources are based.
Get yourself a bargain.
Remember the Arkid satellites? And it was all the old it's from Manchester, Arkid. Oasis satellites.
Love it.
They've actually flown one up on SpaceX rocket that carried the CRS-6, and the other one went up on an ISRO rocket. And they went out and actually proved the technology that they could sort of prospect for water, and so they've been successful. They just haven't got the next bunch of funding. That's required.
We know how much funding is required, and I think that it's a little bit SpaceX in terms of their timeline ambitions. However, it's going to happen, isn't it? It's inevitable, isn't it?
Big time.
There's simply too much money in it to be made.
Well, yeah, but that's the nightmare, isn't it? There's loads of money in it, but you'd also crash it. I think it's the environmental thing that's really interesting. If you can get your heavy industry, when you hear James Lovelock talking about how we may have passed the point of like being able to do something about global warming, it's like we really better put a concerted effort of putting like a huge, like basically an absolutely mammoth task of sorting this out, and maybe asteroid mining is part of solution.
Yeah.
I'm definitely with Zubrin when it's where I think it's all about finding the technological route out of global warming rather than thinking about how you basically wipe out loads of human beings and that's the solution. We're not going to cut back on our consumerism. It's just not going to happen. We need to find the technology. Do it now.
Yes, Matt, I agree with you, but we need to try and cut back.
There's nothing wrong with being efficient. We should be trying for efficiency, for big time. Oh, absolutely, and going for solar power.
But there's just not enough.
But there isn't enough.
Well, we're already seeing it. Yeah. Look what they're saying about global warming, Matt, you know?
It's hideous. It's hideous. It's a nightmare.
Good. It's not good.
Talking of tipping points,
yes,
Jamie, NASA are awarding $44 million to 6 commercial partners in support of tipping point technologies, and one of those will be, in fact, I think Blue Origin won a couple of these, but the most notable is for its Blue Moon lunar lander program.
Oh, lovely.
Yeah, there's a complete list of them on the NASA website, and there's some really interesting projects in there. Yeah,
go Blue Origin, Matt. Whenever I hear Blue Moon, I always think of the Mooney scene in Greece.
Oh yeah,
do you remember that?
Big time. Yeah. Big
Classic. Sorry, what a tangent.
Well, that was a tangent. Here's the big news of the week, though, wasn't it? The big news that happened this week, and we just missed it on the last podcast.
We did,
but it really is the kind of for Americans, they must be very, very excited by the return or the imminent return of human spaceflight back to America after a massive delay since 2011.
Yeah.
I mean, it's just like bad. So yeah, NASA last week introduced us all to the 9 astronauts that will be flying on the commercial spacecraft.
There we go. Who we got?
There is going to be a Boeing orbital flight test, and that's going to be late this year, as predicted at the start of the year on in our year preview. But I'm going to go with it's going to be early 2019 for this. So that's going to be uncrewed. But the first crew flight test is going to be mid-2019 for Boeing, but possibly April for SpaceX. So they're going to be up in front. So let's have a look who's flying the test flight for the Starliner. So there's this guy called Eric Bowe.
Yeah.
And Eric Bowe is a very experienced astronaut. And flew on the final flight of Discovery, STS-133, and piloted the Space Shuttle Endeavour for STS-126. So he's a pilot who piloted both those Space Shuttle missions and has been waiting for a mission ever since, which, God, seems a long time, doesn't it? Christopher Ferguson, who's also piloted a space shuttle, STS-115. He's commanded the shuttle Endeavour, the STS-126, and he commanded the final flight of the space shuttle program, the STS-135. And they're joined by Nicole Aunapu-Mann. And she was chosen in 2013 to be an astronaut after a stellar career as a test pilot, including F-18s and stuff like that. And it's going to be her first trip to space.
Good work, Nicole.
That's a pretty solid crew, isn't it?
That is solid. You know, you'd trust them, wouldn't you?
Yeah, it's rocking crew, that is.
It's rocket crew.
So it is rocket crew. And then we've got the Crew Dragon test flight astronauts, of which there's only 2. You've got Robert Benken, who flew twice on an Endeavour, STS-123 and 130, and he's done 6 spacewalks. And you have Douglas Hurley, and he piloted Space Shuttle Endeavour STS-127 and Atlantis STS-135. And again, he was the pilot for the final Space Shuttle mission.
Nice.
So he flew with Christopher Ferguson, who's on the Starliner test. So these are seriously cool astronauts who've done loads and have been waiting for their next chance to have an amazing moment.
God, well, what a moment. I mean, how exciting is that?
So these are just the test flights, and then you've got the actual first missions, and that's going to be the Starliner. You've got Josh Cassada, who's been a test pilot, a bit like Nicole. He was selected in 2013, And Sunita Williams, who is incredibly, experienced astronaut, and she did expeditions 14, 15 and expeditions 32, 33, and has commanded the space station and has done 7 spacewalks.
Ooh.
Yeah. And Crew Dragon, Victor Glover, who is cool as.
Well, it's a great name again.
Yeah, Victor Glover. He's a test pilot and, again, was chosen in 2013. So that's a pretty cool class of that to have been chosen, wasn't it? The 2013 class. It's like shuttle flights have ended. I'm just going to have to wait until the commercial space gets its act together. And Michael Hopkins, who did Expedition 37, 38 and has done 2 spacewalks.
Good on you, Hoppo.
So that is really exciting, isn't it? And it must have been a proper buzz.
Excuse the pun.
So it really does look like SpaceX are going to win this one.
It's happening, isn't it?
I can think, Elon Musk is going to push them and push them and push them. There are some problems with the SpaceX one though. You remember the Falcon that blew up on the launch pad? Well, the problem with that is it was these things called the composite overwrap pressure vessels, which so they've actually upgraded that particular part of the spacecraft, but that hasn't actually flown yet. I thought when they upgraded it would have been in the Block 5, but apparently not. So they've got to get that done, and then they have to fly that exact setup 7 times before NASA are going to be happy. But SpaceX are really flying 2 Falcons a month now, roughly. So they should be able to smash that out.
Banging them out. Keep going, lads and lasses.
Yeah. It's also worth mentioning that this week was the week we saw a Falcon 9 Block 5 reused and re-land. So I think that might go down as one of the most important things that have happened in a long, long time.
This is getting to be the norm, which is incredible, isn't it?
If this Block 5 rocket can be turned around faster and faster and faster, then we actually might see the reusability becoming a financial no-brainer. I mean, still there's a little bit of a shadow of doubt that you can make it work and make it, better than expendable rockets. But this would really put the nail in the coffin. Unfortunately, I can't see how it doesn't put the nail in the coffin to things like Skylon as well, because it's just like becomes
thing, isn't it?
Because you've got this reusability and it's so much more simple and cheap but I just don't know. I don't know. There's got to be.
You've got to be in it to win it, haven't you?
Got to be in it, but maybe different vehicles do different things, and that there's a niche for
adapt or die.
Adapt or die.
What film's that from, Matt?
I don't know. It's several, I would imagine.
I don't know either. It's got to be from some film. Adapt or die.
Adapt or die.
He was probably in it.
Yeah. I cannot believe how many times I've said this. Rocket Lab have announced that they're going to be launching its business time in November. But we've had that all year, haven't we? We've been saying that they're going to launch this rocket all year. So they've that's a bit of a weird one. But then they're going to do the 4th flight a few weeks later. So they're kind of softening the blow of this continual delay on its business time.
It's getting a bit dull, isn't it? Come on, Lab.
Come on, Rocket Lab. And one little space thing that I think everyone should definitely look out for is the Perseid meteor shower.
Oh, yes,
that's happening this weekend, in fact.
Particularly spectacular this year, Matt.
Yeah.
Because the moon will be a thin crescent and set early, leaving a lovely dark canvas for the meteor's bright streaks and fireballs.
Absolutely. I'm going to be out there with my camera. I just hope.
Let's just hope it's clear.
We get some clear weather this weekend.
Because we got bugger all with the blood moon at this side of the world.
Yeah, we really did. I actually did see the moon behind cloud and could see it become a crescent behind the cloud. I just didn't get the blood effect. But
what was cool is
weird.
We saw lightning that was like red, kind of blood lightning, which was very cool.
Blood red lightning.
Yeah.
Well, that's even cooler than a blood red moon.
It is cool, but I was so up for the moon that I was kind of like, still. First world problems, Matt.
Absolutely.
According to NASA meteor expert Bill Cook, the shower should feature 60 to 70 meteors per hour at its peak.
which is really good.
It's a lot.
Yeah, that's good. That's a good little ratio.
Hey, Matt,
I hope it's
that's 1 a minute, roughly.
You're right, Jamie. That's a good
and people say that I'm not the intelligent one.
It's like when I'm driving down the motorway at 60 miles an hour and I think every mile's a minute, and I get really excited by that.
Hey, Matt, I'm going to make you more excited by giving you my space fact of the week. Matt, it's surprisingly hard to go to the sun. Let me talk to you.
Tell me.
It takes 55 times more energy to go to the sun than it does to go to Mars.
See, it's so counterintuitive. You think you could just sort of fall off the Earth and the sun's gravity would just take you there.
Right in.
It's 99.8% of the mass of the solar system. You'd think you'd just get, like, you'd almost be like if a black hole was there, you'd instantly assume that we'd all be sucked off.
Let me ask the question. Why is it so difficult? So our planet is travelling very fast, about 67,000 miles per hour, almost entirely sideways relative to the sun. The only way to get to the sun is to cancel that sideways motion.
Yeah, well, I mean, it is what it's like. It's if you've got a tennis ball on a piece of string, it's got to go quite fast for the string to remain tight, right? So it's, in other words, the Earth has to be going fast to remain in orbit around the sun. That is what an orbit is, and that's why spacecraft have to go very, very fast so they can get into orbit around the Earth, right? So yeah, the Earth's going really, really fast. So if you want to reduce your orbit, you've got to slow down. And it's do you know how the solar Parker? So we're talking about this because the Parker Solar Probe, which takes off very soon on a Delta IV Heavy, has got to make this journey. It's got to make this journey, Jamie. So it's. Do you know how it does it? And this is just absolutely incredible.
Go on.
Well, it's on a Delta IV Heavy rocket, and the reason being you need like a really powerful start to this mission because it's not particularly big, but it needs that like push, and it's going to go into solar orbit and use Venus as a gravity assist to slow it down, to get its orbit down. And it's going to do 24 close approaches to the sun as part of this, like slowing down and using Venus 7 times.
That's crazy
to get it like to reduce its speed in that direction. However, it's actually going to speed up the actual probe itself.
Huh?
Well, it's you've got to think of the speed and the velocity as vectors. So its speed is different to its velocity. It's got a velocity that it needs to get rid of in one direction, but it needs to increase its velocity as it does these orbits around the sun. So it will become the fastest ever human-made object and will be clocking 430,000 miles per hour on its final orbit.
Fast. That's fast.
Well, it's fast enough to go from Philadelphia to Washington in 1 second, or if you like, from Philadelphia to Tokyo in 1 minute.
Matt, when I was in primary school, my nickname was First Class Franklin because I was the fastest kid on sports day.
Were you really?
Yeah, so I can relate.
That's pretty cool.
Yeah.
Yeah. So this is going to be humanity's first visit to a star. We've never actually got... And so apart from all like just getting there, the Parker Solar Probe is just an amazing piece of kit. It's just ridiculous.
I hope it's going to wear some sun cream, Matt.
It has got to wear sun cream. Get this.
I mean, what's it made of, dude?
Here's a really interesting fact for you. This is definitely a fact. So in space, you can have a temperature that can be thousands, if not millions of degrees, that doesn't actually provide, it doesn't actually give you a significant heat, right? So temperature and heat are actually two different things. So temperature measures how fast particles are moving, and heat measures the total amount of energy that's contained within that. So if you're in something where the medium is quite, nebulous, I suppose, very rare, then even though you've got very, very fast-moving particles, i.e. very, very high temperatures, you might not actually have that much heat. So this actually relates to the sun shield on the Solar Parker probe. So it has this heat shield that's 4.5 inches thick, and it's a carbon composite, which is a foam of carbon sandwiched between two carbon plates, and it basically is exposed to temperatures of several million degrees, but the heat is only about 2,500 degrees Fahrenheit or 1,400 degrees Celsius, which is still ridiculous, and that's why you've got this carbon composite shield. And all the instruments on the telescope remain at room temperature.
Would you still be able to cook an egg, Matt?
Well, 2,500 degrees Fahrenheit or 1,400 degrees Celsius is as hot as lava, or much hotter than lava. Lava's about 1,200 degrees Celsius. So it's considerably hotter than lava. So yes, your egg would be completely eviscerated.
I think it would definitely be sunny side up, shall we say.
Do you want to hear about do you want to hear about the instruments? The instruments on this technological marvel.
Do I?
4 instruments, the fields, and I've never actually worked out what fields stands for, but it might just be called fields.
Oh, I'll tell you later. It's a tricky one.
It is
I'll
a tricky.
Speak to you
nice. I wonder if I stands for instrument. Absolutely bound to.
Wrong, but
it measures the waves and turbulence in the inner heliosphere with high resolution. So you can understand the fields associated with waves, shocks, and magnetic reconnection as the field lines explosively realign. And then you've got WISPR, which stands for Wide Field Imager for Parker Solar Probe. So, and that is an instrument that looks at the large-scale structure of the corona and solar wind before the spacecraft flies through it. And it's about the size of a shoebox. So that's like so basically it's going to be taking pictures of the coronal mass ejections and other jets and things that are coming out of the sun. Actually, as it's taking these pictures going away from the sun, those jets, etc., may actually overtake the spacecraft and because they're going so fast. Even though that's going 470,000 miles an hour, it'll kind of overtake it.
My head hurts again, Matt.
And then you've got the solar wind, electrons, alphas, and protons investigation, or SWEEP.
It's my kind of investigation.
And I believe that's one of the instruments that's actually outside of the protective shield. And so it's had to be made of titanium, zirconium, molybdenum, and it has a melting point of 4,260 degrees Fahrenheit, so much higher than it's going to be exposed to. And it's been specially built using lots of different techniques. But I think the craziest bit, obviously, is you need cables that carry the information from these instruments. The clever engineers had to grow sapphire crystal tubes to suspend the wiring, and the wires themselves are made from niobium.
Matt, did you know that the first successful synthetic crystals growing process in the late 1800s was the Venule method? Matt, this all sounds like sci-fi, but it's not. It's real.
Doesn't it? It's not. And then my favourite instrument of them all, because it uses a symbol in its name, is ISIS, spelt I-S-O, but the O has a dot in the middle, which is the symbol for the sun. So I-S-O-I-S, ISIS. Not to be confused with ISIS.
Yeah, I was going to say, do you reckon that's why they put the O in there?
Oh, yeah, maybe. Yeah, maybe. Yeah. And that basically uses 2 instruments to measure particles across a wide range of energies. So 2 energetic instruments are called the epi-low and the epi-high. So energetic particle
stands to reason.
Its orbital period will be 88 days. It's going to last 7 years. It's only 635 kilograms, the whole thing. It's only about 3 meters tall. So it's not massive. And the solar arrays, that's the clever bit. They kind of have to tuck themselves away as it gets near the sun because they'd get damaged. So that it has to fly in a really special way and have these amazing maneuvers to stop the solar arrays getting completely trashed. And it's basically going to solve some of the biggest mysteries of the sun. The main one being, why is the corona so much hotter than the surface of the sun? And one of the leading experts, and the theory that's really being tested is a theory posed by Professor Parker.
Yes, he's back.
There we go. Here's the list of our Skylon. Basically, this podcast would not be possible.
This is all down to you guys contributing.
And all of that is genuinely to the legends that are Bob Hodges,
yes, Bob.
Word Up, Catherine Carr.
Catherine, you know what you're doing. You rule.
New legend, Darren Fuchs.
Darren, you are. He's the man, isn't he?
Totally the man. Erin Edwards.
Yes, Erin, again. Big up yourself.
Jeffrey Marlam.
Papa Jeff, Big Jeff.
The Big JM. John Bennack.
Big John, yes.
Super legend. I can barely say this name without the embarrassment of riches that this guy has given us. Julio Aprea.
Oh, I mean, the gift that keeps on giving.
Justin Roberts.
Justin, thank you.
JR. I like to call him JR.
Oh, JR, yeah.
Karel Sim.
Karel Sim, I love you.
Matt Gilliland.
The infamous MG.
He's the best of the Matts. And Richard Swain.
Richard, listen, you're very special. Listen, thank you, everyone. And like Matt says, we don't want to ever do adverts, and so this means we rely on your generous contributions, or we couldn't really do this. So thank you so much. Keep it up.
We finally managed to come up with a format for our space news. It will get better. So we've got a monthly space news little thing, little 10-minute monthly space news for our patrons only. It's quite special. George does all the music for me, and so that's quite fun. It's quite fun. Jamie and I are going to swap reading the monthly space news and see who can do it in the most ridiculous voice that doesn't get irritating for 10 minutes.
Yeah, please let us know if that's annoying. And we'll just do it. We'll just do it anyway.
So by the end of the year, we want to vote on which one was your favourite. So patrons only that.
Let us know what you think.
Jamie, shall we let the Spodcats go?
Yeah. Thanks for listening.
Right. Thanks for listening. No interview this week, so you can go home early.
Yeah, exactly. You're let off the hook.
Jamie.
Yes.
We're done now.
You're done though.
They've been listening to the Interplanetary Podcast. Putting the ace back into space. Bye.
Bye.